everyone, and welcome to the event FogProtect in Overview. We are here today to discuss the FogProtect project, its goals and objectives, and its results. And it's with great pleasure that I introduce the first speaker, Ricardo Vitorino from Ubiwhere, who will present the FogProtect project, its goals, and its objectives. Ricardo, the floor is yours.
Thank you, Anna. Good morning, everyone. Thanks for joining today. So, as Anna introduced, my name is Ricardo Vitorino, and I work at Ubiwhere as Head of Innovation for Smart Cities. And FogProtect stands for Protecting Sensitive Data in the Computing Continuum. So, if you are interested in researching innovation actions such as this one, feel free to get in touch with us, but I'll just briefly introduce you to the project. So, when we consider sensitive data, we mean about important information that has the potential of severe consequences if it's compromised. We typically link it to personal data. So data about information that identifies yourself and your attributes of a personal or of a data subject, which could be used to humiliate, harm, or extort in any way individuals. But it's not only that. So we also consider data that is linked to corporates and organizations, which should be accessed only with restricted access. So if it gets compromised, read, changed, or destroyed, will impact the corporate's activity. So it could harm entire companies and institutions to decrease their profits or disrupt markets and harm them in their own business or activities. Regarding the data processing, so as we improve the information technology in our world, we move from a way that, or an environment where data has been processing at highly processing servers at the cloud level, aggregating data from multiple devices, into a world where we have several layers of data processing. So this introduces the computing continuum, meaning that more and more we see powerful devices being deployed closer to the data sources and doing this processing so that it becomes more distributed, faster, more efficient, and less expensive also for the deployment regarding those individual devices. And this compromises a few challenges because you see now that there's the whole flow of information being processed, and if we consider that sensitive data should not be compromised, being them linked to personal or corporates, we see different challenges in this roadmap of computing continuum. And most of those are related to the limitations of the nodes, which are closer to the data sources and to the end devices, which constrain the data protection methods used. These are heterogeneous, meaning that they have different hardware capabilities, different operating systems, different firmware versions, and this heterogeneity of fog nodes, as we call them, and end devices hampers consistent security, meaning that it's difficult or challenging to harmonize the different security methods applied with this heterogeneous ecosystem. Furthermore, there's also the metadata linked to the node connectivity, which can leak sensitive information, and the mobility of these devices, meaning that they are not static in a same location for the whole time, but they actually move around, which require the compliance with changing data protection policies by using different infrastructure mechanisms. Furthermore, these frequent changes at the edge imply and require highly dynamic changes of data protection risks and full transparency of stakeholders so that we avoid the unauthorized data access. So FogProtect, in a nutshell, tries to tackle these challenges by focusing on the cloud computing continuum and the data end-to-end sensitive data value chain, from the data subject to the data user in different use cases. In a nutshell, in a very brief figure, we summarize FogProtect, a research and innovation action funded by the European Commission, as this producing these 4 building blocks: a secure data container for data portability, end-to-end security management for data protection, ensuring different policies to be handled, data protection risk management to analyze the risks identified by different use cases and scenarios, and then the data protection aware adaptive service and resource management for proper orchestration and deployment and integration of different policies and accessing the security capabilities. So these increased management capabilities, these 4 building blocks, come from an extensive research done from the last almost 3 years now, and it's been focusing on exploring novel technologies for the cloud computing continuum, meaning that it orchestrates different fog nodes and end devices, but also cloud servers. It covers the whole value chain from different data subjects to different data users using different policies, as you'll see later on explained by the different use cases we have developed. So these 3 use cases are complementary and cover manufacturing, media, and government. So 3 different use cases with different policies and different scenarios and needs. But the idea is to always explore the main technology innovations which come out from the project. As I mentioned, the secure data container for data portability, the adaptive service and resource management, advanced data protection policy management, and dynamic data protection risk management models and tools. And the 3 use cases by the following presentations will further explain how these are done in practice in these scenarios. Furthermore, this has been worked from a consortium of 13 organizations. This means that the partners developing this project and developing these solutions have been working for the last almost 3 years, organizing different meetings and organizing the work in different work packages and tasks. If you're not familiar with this sort of project, this essentially is tackling challenges proposed by the European Commission on the cloud computing and the ICT sector. And most of the partners have already worked before in previous initiatives and already knew each other from different research actions. Most of us are also part of the Big Data Value Association, now known as DIRO as well, standing for Data, Artificial Intelligence and Robotics Partnership. And here we foster the public-private partnership on data processing and cloud computing technologies, but also more and more on the IoT and edge and leveraging this computing continuum. So Ubiwhere is the project coordinator, which I represent. An SME from Portugal, but we have different universities working here. We have University of Amsterdam as the technical coordinator, but also the University of Southampton proposing novel technologies for risk management. We have the Technical University of Vienna as well, and Paluno working so the University of Duisburg and Essen. So basically proposing different solutions for orchestration. And then we have different industry players, ATC, IBM, Nokia, Thales, and also VRT with different technological components and use cases, as you will see explained by our colleagues from Nokia and VRT in their different use cases. So these will be presented by different organizations with different competencies, and we are keen to showcase the capabilities of our technology and promote and invite you to join this ecosystem, since we look forward to involving more entities and contributing to the future digitization needs of industry and public sector, but also deliver new cloud-based services and infrastructures in Europe and foster this industrial capability in the cloud computing sector. So we are more and more contributing to the open source communities, to the different components we also integrate, but also the ones that we have developed, making them available for others to use. And we look forward to having you on board and joining our ecosystem and contributing to it as well. The project will end this year, so we are closing the project in December in 2022. So, but we will not stop there. So, as this has come from different initiatives from before, individual and also from partnerships, we aim to continue contributing to this landscape and to this innovative technology. So we are here for the long run to keep enabling end-to-end dynamic protection of sensitive data from the edge to the cloud. So please get in touch with us. Enjoy the rest of the webinar. If you have any further questions or you would like to discuss specific details of it, please reach us at fogprotect.eu or say hi at fogprotect@ubiwhere.com. I'll be happy to join the conversation. Thank you so much.
Thank you, Ricardo, for your brief presentation of FogProtect. It was quite useful to introduce not only the project, but the next speakers who will dive into the use cases. So our next speaker is João Garcia, also from Ubiwhere, who will present the first use case. João, the floor is yours.
Thank you. So hello, everyone. I'm João Garcia from Ubiwhere. I will present use case 1 of FogProtect, which regards smart cities. So to provide a little bit of context, Ubiwhere, we've developed a platform that's called the Urban Platform, which tries to give a holistic view of the city to city managers. So in one place, it gathers information from different city domains, such as traffic, parking, air quality, etc. And it shows it in a single place where, apart from seeing the information, we can also do some cross-domain analysis based on this data. This is a complex platform, but I will speak of the occurrence management part of it. So there's a component of the platform which allows city managers to look at incidents within the city reported by citizens. So they can see the cause, they can see images associated, and they, apart from that, can delegate vehicles and agents to solve whatever problem there might be. Another product from Ubiwhere is the smart lamppost. So this is a modular lamppost where we can install different components that live within this lamppost. So these can be cameras, 5G small cells, EV charging stations, etc. And the information gathered and managed by these lampposts is also integrated in the urban platform that I showed previously. So for FogProtect, we are demonstrating a use case where we have a CCTV camera network installed in the smart lamppost, which monitor the city, and this can be relevant for different city entities such as municipalities, police, firefighting, etc. In the smart lamppost, we process the video locally, so we are distributing these processings to not only store the video locally, but also blur any personal information that might be in the video. And this will later be available through the urban platform. There will be different levels of access to this information. So entities such as firefighters, which are more critical, can request access to the raw video, but city managers don't need this type of information. So they might just be able to access the blurred video, and people such as city analysts could access just inferred data from the video, for example, the number of people at that given place at that given time. For FogProtect, it's clear that street furniture can be vulnerable, and since this system handles personal data, it is important that data security is guaranteed. So this is a very high level diagram of the use case. So below we have citizens that through a mobile app report occurrences. We have different type of users that can request different data from our platform. The cloud center represents the backend of our solution, which will receive the requests and redirect them to the relevant lamppost of the request. So the lamppost has an API through which it provides the different types of video or files that it has stored locally. Yeah. So this is also the architecture of the different components within this use case. So I won't go into too much detail, but we have the fog node represented here. And when a tampering event is triggered, it will send a message to the event management and recalculation models, which apart from handling the messages, they will calculate the risk level of such an event to the system. This will be sent to the adaptation components, which will calculate different adaptations in order to lower the risk level of the system. The security orchestrator has the job of translating these adaptations to policies, which will be implemented by Fabric, which apart from this also provides dynamic access control to the system. Here I have a demo video of our use case. I won't be showing it all, but I just wanted to show this is the urban platform. If I go to this time, we will see a user requesting the raw video at a given time frame. And here we can see from at Ubiwhere premises, a colleague of mine just walking around. So this is the raw video. But if I go a bit further ahead, we can see the user is requesting the blur video. So the user has access to all these types of video. And we can see that we can really identify the colleague that was in our premises. After this, we will show how other different users don't always have access to the video that we just see. So this user wouldn't be able to see the raw video. But I'm going to jump a bit forward. So I'm going to show this is a bit more technical, but this is we have different terminal windows where through the first one, I will trigger a tampering event of the system. So the system in this case is being attacked. In the other terminal windows, we are seeing FogProtect handling this event. So it received the tampering event, and the different components, as I explained previously, are processing the different are doing their job. So calculating the risk, calculating adaptations, and implementing those adaptations. If I jump a bit forward, because you can see this takes a bit of time, but in the second iteration of FogProtect, this was the first. In the second, this process will just take a few seconds. So it has been improved. But here you can see that the user will request again video from the same time frame, but it will be rejected because we no longer trust this fog node, and the FogProtect blocked access to its data, so preventing the loss of integrity of data within the system, because we don't know what has been done to it. In the same way that we blocked access to this fog node, we can also restore. So if at some point we see that everything is fine again, we tell the system that, okay, we can trust this node again. An event similar to the last one will be sent to the system. A new risk level will be calculated, and eventually FogProtect will understand that we can again trust the node, and will grant access to it again. So it's going through the same workflow basically of calculating the risk level and the adaptations, and eventually we will reach a state where we doing the request again, we will be able to again access the video. So just to show here that we can again access the video that was previously being blocked. This use case demonstrates how FogProtect can provide data protection through the whole computing continuum for such a use case. And it also works for the objective 6 of FogProtect project, which is to validate the project with 3 complementary use cases. We can see also that's interesting that all the technical work packages are contributing to this specific use case to provide the data protection. And it will be clear when the other use cases are presented that these components are generic enough that they can also be used for a very different use cases, which provides or showcases how FogProtect is adaptive and can be implemented in different situations. in the end, it's also clear that, and it's very relevant, that FogProtect provides adaptive data protection service to reduce the risk level of systems in general. Going forward, since we are nearing the end of the project, we want to improve upon this use case, where we will have more than one fog node in the demonstration, and the goal will be that instead of blocking access to a fog node to protect from the loss of integrity, we will redirect requests from one fog node to another if the fog node is available. So it has to be a fog node that has the capability of computing or processing this type of video images, and also be filming more or less the same area so that we can capture the same information. So the goal will be, when there's an attack, this can be a different attack, such as tampering of the video files. Instead of simply blocking a node, we will redirect to a relevant one nearby. And yeah, that's it from my part. Thank you, everyone.
Thank you, João, for clarifying the first use case. So we will now move on to the second case, which will be presented by Jens Kuh from Nokia. Jens, the floor is yours.
Yeah, thank you very much. As said, my name is Jens Kuh. I work in Nokia in the area of digitalization of the supply chain. And this is use case 2, which is about smart factories. So the first slide should show a little bit our motivation for the use case here. So we have been seeing that smart factories or digital factories typically are not created on a green field, where they are built and with all the newest and latest digital technologies in place. So basically, what we have been seeing is that smart factories, as they are deployed today, are typically the result of a transition which took years, sometimes even decades, from a formerly traditional non-digital factory to a smart factory. And that means the IT systems and also the machines used in these smart factories are sometimes very new, but also sometimes very old, and also based on very old IT standards. And in addition, they are also typically not off-the-shelf systems, but typically highly specialized and custom-made. And as said, since these smart factories as they are today are often the result of a decade-long transition, cybersecurity and GDPR compliance was often not the focus by the time when these systems have been designed. But they have to be now, right? And that would mean that these systems either need to be upgraded or somehow to be made fit for the modern world in this area. And for this, we want to show that FogProtect is able to retrofit, to upgrade these kind of factories to modern standards in the area of cybersecurity, GDPR compliance, data protection, without having to disrupt and without having to replace.
I'm sorry to interrupt, Jens.
Current technology.
We cannot see your presentation. You might be in presenter's mode, so you need to turn your presentation into, you have to open the presentation, I'm sorry.
Can
Otherwise,
you see it now?
Yes, but we cannot follow you, so you need to open the presentation, I'm sorry.
What do you mean? Can you see my screen now?
Yes.
Motivation.
Presentation mode.
Yes, but you need to choose at the bottom the presenter's mode.
Like now?
No, not yet.
That's what I did. I see it now in full screen on my screen, and I've used presenter's mode.
I think you have to reshare the screen to show what the full screen and not the PowerPoint.
Thank you.
Okay, let me try then sharing again. I'm very sorry for this.
No problem.
I will share my entire screen. Can you see my screen now?
Yes, perfect.
Okay.
Thank you. Perfect.
Great.
Thank you.
All right. I'm so sorry for this. So this was the slide I was talking about, the motivation, right? Let me then go on to the next slide. So before I want to talk about the use case itself, I would like to introduce the environment where we have been implementing this use case. This is what we call Nokia Factory in a Box. So basically, Factory in a Box, or FIAB as we call it, is a concept where we at Nokia investigate how it is possible to deploy modular production capacity in very small units, such as you can see here on the screen, for instance, shipping containers. The idea behind this concept is that we want to be able to, for instance, deploy very quickly production capacity, for instance, in case of disasters, for disaster recovery, but also to have modular production capacity, for instance, for a new product implementation, for product prototyping, perhaps having a production line close to our R&D facilities so that our R&D colleagues can be part of the production process, or also to meet country of origin requirements, for instance. So this is how it looks in a couple of pictures. So here, for instance, you can see how easy it is to transport and ship and deploy this kind of mobile factories everywhere in the world. This is how it could look like on the inside. This is, for instance, one of our labs where we are trying out new and novel technologies, which we first of all try in this small environment and later on scale to our real factories. So basically, this setup is our was the environment where we have been implementing this FogProtect use case. So, and about the use case itself, concretely, what we want to show with this iteration of the use case is how we are using FogProtect to retrofit an existing factory IT setup to be on par with the latest and greatest developments in data and cyber threat protection functionalities. And we're demonstrating how FogProtect is helping us to quarantine factory process data, which is generated during a possible attack. And we're also showing how FogProtect is helping us to mitigate risk to factory worker safety by directly influencing production processes during an ongoing attack. So this is the block diagram, how the setup is working without FogProtect currently in our factory. So it's basically a setup where we have a robot that is collaboratively working with the workers which are operating it. But of course, in order to ensure worker safety, we have certain security protocols in place. For instance, that the worker always has to wear a helmet when he's close to the robot and may not be operating the robot without the proper security gear. And in order to ensure that these security protocols are always followed and that the robot will stop in case they are not, we have a video analytics application which is monitoring the area in front of the robot and is constantly evaluating how many workers are near the robot and how many of those workers are not wearing a helmet, for instance. So, and this kind of information is then being processed by the health and safety application, which will eventually decide whether or not, in the current situation, it is safe to start or stop the robot. So you can see this kind of video analytics is part of a very critical factory infrastructure because it basically determines whether or not everyone who is close to the robot is safe. And of course, any kind of production, any kind of data that is produced in the factory, let it be production data, let it be the data which is generated out of the video analytics, is being stored for archiving processes in a remote data center. So that is the situation without FogProtect. And the next slide shows how FogProtect basically plugs into the scenario and upgrades it with intruder detection and risk mitigation capabilities. So everything that's blue here is now FogProtect. So we see that a Wazoo component, which is monitoring the video analytics component, would detect all kinds of suspicious activity, right? So this is what's meant here with intruder alert. This message is then being picked up by the core components of FogProtect, the risk analyzers and adaptation components, which are evaluating how much this kind of activity which has been detected is posing a risk to the factory. And based on these calculations, it would then, for instance, inform the health and safety application that the output of the video analytics is being compromised. So the integrity of this component is very low, which then, of course, could immediately lead to the situation where health and safety decides to stop the robot. Another result of FogProtect's risk analysis would be a policy update, which is then instructing Fabric, which is controlling the data flow in and out of the factory to limit, for instance, this data flow, to limit certain users which are in the factory while it's under attack to access the remote cloud center. Or, for instance, to divert any kind of data that is being produced during the effect to some kind of quarantine database, because we do not want, we consider data that is produced during an attack in the factory as being compromised, and we don't want to store it along with our formerly non-compromised data. So basically what I want to show here is how the FogProtect solution can be easily plugged into an existing factory setup without having to disrupt or replace any of the existing components. So basically that already brings me to the, I would say, benefits that we see for this particular use case. As said, these kind of smart factories are very often the result of a year-long transition. They have a very heterogeneous IT environment, which can be partly very old, partly very new, but in total, very much likely is not up to date with the latest and greatest cybersecurity requirements. Of course, a factory operator could replace all this with modern technology, but that would be very costly, and it would also disrupt factory operation a lot, and you would have a lot of integration efforts again. So we believe that this FogProtect solution provides a much easier and cheaper alternative to upgrade factories to latest cybersecurity requirements, right? You can plug it in, as you have seen it on the slide before. You have some kind of central component that is dealing with all this threat detection and threat mitigation activity, meaning you only have to update in the future that one central FogProtect component if there is new technology in this area available. You don't have to integrate or replace any existing technology that you already have in your factory, and that is also working and proven to be working over the last years. And I think that concludes my presentation of the smart factory use case of FogProtect.
Thank you, Jens, for introducing the second use case. So now we will move on to the last use case number 3 by VRT. And we have with us Klaas Baert, who is from VRT and will introduce this last use case. Klaas, the floor is yours.
Thank you, Anna. Good morning, everybody. I'm Klaas Baert from VRT. And VRT is a Flemish public broadcaster in Brussels. And I work for VRT Innovation, where we explore new technologies and applications in media context. And we have a current focus on co-creation, interaction, and urban storytelling. And this leads me to our use case definition. So in the FogProtect project, we brought a video booth prototype called Media on the Road, which is our locality-based scripted story catcher for user-generated content, a part of our ongoing research around interaction and co-creation. And it's a prototype that is about to be scaled up and possibly productized, which is also relevant in this context. Our Media on the Road prototype started a few years back when it traveled around Europe together with journalists in order to create a web series around the EU. So people in the street were asked their opinions on the EU. And this leads me to one of the properties of Media on the Road of a video booth is that it might deal with sensitive data. Another property is, in this case, was a version that should work fully offline, which leads me to the property that possible sensitive data might be stored locally for a period of time before transmitting it to the cloud. This summer, we had an installation at an event where children could walk up to the video booth and have a virtual meet and greet with their favorite character from a kids show, a television show. And this was a collaboration with a commercial agency. And in the future, we probably will have more and more of these types of events. And this raises the need of a shared infrastructure with other organizations. And then lastly, we are dealing with personally identifiable information, of course. In some use cases, if the use case requires it, we use AI in order to detect or to create metadata from the video, which might contain personally identifiable information. But of course, we sometimes just ask the subject for name or email if also the use case requires it, that we can keep in contact with the subject. So if we translate these properties to challenges of FogProtect, then we have management of secure sharing of media and data between organizations. We need a role or attribute-based access to data based on a dynamic metadata model. We need securing of temporarily stored data in the edge or fog mode. So let's look now at the solutions that we have explored in the project. I made a very oversimplified drawing. I want to keep the explanation functional rather than technical in this presentation. So it's a very simplified diagram where we have on the left, we have the video booth operated by a video booth operator that is allowed to upload video and metadata to the cloud. And then on the right side, we have an editor that is consuming those videos in order to create content with it. Also oversimplified, but this in this image we see FogProtect wrapped around the backend. It's more complicated in reality, but it tells a bit the same story as Jens suggested, that actually no changes were necessary in the booth backend. So if you imagine a large company with lots of legacy and third-party software, which is very costly to adapt, then you might see the benefits of a system like FogProtect that wraps around it and catches all this functionality for you. Also on the tooling side, let's say on the editor side, the tooling that wants to fetch the videos, no alterations were needed. Now let's introduce this other company. So we want to give another company access or partially access to our infrastructure. So now the editor is actually belonging to another company. They don't actually log into the VRT backend. Like I said, no alterations were made in the tooling, so they just see their own interface, and they log into their own identity provider. So they have only their own token from their company. And with that token, they are fetching videos from the VRT backend. Now, this token doesn't reach the booth backend, otherwise it would be, of course, blocked. But FogProtect checks if there is a corresponding token or role available at VRT for that token for another company. So the identities are federated between both identity providers. Resulting in that the booth backend just receives, in fact, a call with a VRT token. So it doesn't know that it actually comes from another company. It doesn't need to know. It can know, but in this case, it doesn't need to know if it comes from another company. And the fact that it doesn't know also results in the response that it sends. We didn't do any alterations, extra filterings or we didn't implement any filtering logic inside the VRT components, but we just return all videos, and on the way out back to the client, the FogProtect filters out the response horizontally and vertically, meaning that it checks for the organization property to see which organization the call belongs to. So it filters out any other record from other organizations, but also vertical filtering, and this is based on the role. In this case, we stated that an editor doesn't need to have personal identifiable information in order to do their job. So they aren't allowed to see any personal identifiable information. And this is also this also indicates how you could enforce GDPR rules in your company, which might have many toolings or third-party and legacy software. Also, FogProtect is monitoring all traffic, of course, in order to detect malicious intent, but we are also using it in our use case to enforce service level agreements. So if we have another company, we might restrict access to our resources by saying, for instance, that an editor can only access the videos that many times within a certain window of time. So if it exceeds this threshold, further requests for within that period of time will be blocked by FogProtect. Now, if we imagined that we would just block the videos in our use case, but on the other side, if this would happen with a video booth operator, this would mean that the video booth itself would be rendered useless. And this might be not what you want when you have a contract with another company. Maybe you want to have all the video booths at the events that are currently running. You want them to remain operational. In this case, we envisioned that if a video booth operator on user level might be also on role level, even on organization level, if the SLAs have been trespassed and video booth operator is blocked, then the videos are still uploaded, but not to the video booth backend of VRT, but to a quarantined zone. And this is actually functionality that can be, you can imagine using the same functionality, you can imagine other scenarios where, based on the threat level, you might say that your data follows another service function path where more metadata, for instance, is extracted when the threat level is low, but when it gets higher, you make sure that your data follows a different path. And we saw it in different use cases where video might get blurred or something like that based on the threat level and the policy adaptation that results from that. Now, one thing with monitoring traffic is that when we're talking about malicious intent and an actual denial of service attack, is that all this monitoring of traffic will still possibly cause a loss of availability of your system. It might cause overload, and this is why this is why at a certain point it's possible that FogProtect decides to actually cancel the federation of identities, thus blocking every call coming in, not Well, from the first proxy it encounters. So any token from another company is rendered useless to enter even the FogProtect system. So traffic is no longer monitored, and the user token is blocked, or even the whole company is blocked. So it's all about the tipping the balance here between shall we block it temporarily, shall we block it by denying federation of identities, by denying the whole company access, and things like that. So this is all managed within the FogProtect logic. So if we tie these solutions into FogProtect lingo, then we're talking about secure data container technology for secure data portability, data protection policy management techniques, ensure data protection while optimizing system performance and cost. So this is the tipping of the balance between blocking and maybe have loss of income and things like that. And of course, federation of the identity management in a nutshell. Thank you.
Thank you, Klaas, for such a nice presentation. So thank you, everyone, for clarifying to our viewers and to anyone that wants to learn more about FogProtect, what the project is all about. I'd like to thank, obviously, the speakers and also the audience. If you want to learn more about FogProtect, if you have any doubts, or if you want to just get in touch with us, as Ricardo presented before, I challenge you to contact us through the website, fogprotect.eu, or even through our direct email, fogprotect@ubiwhere.com. We're always available to clarify anything that might not have been totally explained in this webinar, or to just talk about the project. Thank you, everyone, for joining us, and we hope this was nice moment to learn more about this project. Thank you.